Hey guys, welcome to week 3 of creative coding. So in this class, we are going to be talking about computational color and how to export our designs from P5.js as both images, high-res images, and vector files. So this is Johan Eaton's color wheel and is the color wheel that most of you are familiar with. Everything on this wheel can be created by using our primary colors of red, yellow, and blue. Although this wheel makes color look very simple, it is actually one of the hardest things to master. It is both subjective and highly dynamic. Our perception of a single color can drastically change based on what other colors we pair it with. Here's an example of how visually dynamic color combinations can be. This looks like two different color backgrounds, where the squares in the center switch colors. This is actually made up of 3 colors, not 2. The color of the squares in the center is actually exactly in between the 2 background colors on the hue spectrum. The eye is trying to compare all 3 colors and tricks the brain into thinking there are actually only 2 colors, when in reality there are 3. So if you take away the 2 background colors, you can clearly see the 2 center squares are in fact the same color. Here's another example. The 2 small squares look like they are exactly the same color, but in actuality, they are completely different. Because the 2 squares are the same distance from its background color and brightness, they appear to be the same. Again, if you remove the background, you can obviously see the difference between the 2. This is proof that color theory is extremely important when it comes to the visual arts. Since we are working with the screen, we have to look at color in terms of light. When you paint something to get a darker color, you usually mix more colors together, and eventually you get black. When it comes to screens and light, to get a darker color, you need to take color away, and the absence of color is black. But if you mix all the colors together on the screen, you get white. You can see how this works actually through a prism. So if you shine a white light through a prism, it'll, on the other side, display all the colors of the rainbow. And the opposite is the same. If you shine all the colors of the rainbow through a prism, then the output is just going to be one white beam. So here are the 2 color wheels that are important to us. On the left, we have our traditional wheel made up of red, yellow, and blue, the primary colors. On the right, we have our screen-based color wheel, which is made up of green. On the right, we have our screen-based color wheel, which is made up of red, green, and blue, or RGB. When working with any screen, whether it is a computer, a phone, or a television, all the colors are made up of a combination of red, green, and blue. This is because all screens that we use today use red, green, and blue lights to project pictures onto the screen. The range of these colors goes from 0 to 255. 0 means that the color light is off, and 255 means the color is at 100% on. If all are 0, it's black, and if all are 255, it's white. So those of you who are nerds like me and are wondering why 0 to 255, this is the reason. So a byte, when it comes to binary, a byte is made up of 8 bits. And there are 256 variations of bytes. So 256 variations of makeup of zeros and ones of 8 different digits to make up a byte. So because of that, because there's 256 variations, there are only 256 possible options for a value for red, green, and blue. So that's why the range is between 0 and 255 possibilities. So that's the maximum number of possibilities that we have when it comes to working with bytes and bits. Now, when it comes to computational color, RGB isn't the best color mode to be working with, mainly because it is really difficult to figure out how to create colors by mixing red, green, and blue. So for this class, we'll be using HSB as our main color mode. That stands for hue, saturation, and brightness. Hue is the basic color wheel and ranges from 0 to 360 degrees. So it's this portion at the top of this cone. So 0 is going to be red, 120 is going to be blue, and 240 degrees is going to be green. And 360 comes back to red. Then we have saturation and ranges from 0 to 100%. So it's basically from the center of this circle out to the perimeter of the circle. So this is 0%, and this is going to be 100%. Then lastly, we have brightness. Also, it's going to be 0 to 100%. And you can think of this whole thing as being a cone. So the brightness, or in this case, the V stands for value, which is another way of saying brightness. So for brightness, it's going to be from the top of the cone all the way to the bottom. So 100% brightness at the top, and 0% brightness is at the bottom. So the bottom is going to be black regardless of the saturation and hue. If the brightness is 0%, then it's basically like turning all the lights off. So here's an example of the color breakdown for both RGB and HSB. So red, green, and blue versus hue, saturation, and brightness. So for RGB, for white, it's all of them are going to be 255. For black, all of them are going to be 0. For red, it's just going to be red is going to be on. For green, just green. For blue, just blue. For yellow, it's a mix of red and green. And for magenta, it's a mix of red and blue. For hue, saturation, brightness, white. So as long as brightness is 100% and hue and saturation is 0, then it's going to be white. As long as brightness is set to 0, it doesn't really matter what hue or saturation is, it's going to be black. For red, again, red starts at 0 for the color wheel for hue, and then saturation and brightness just have to be higher than 0 to be able to see the color. And green is again going around the color wheel for hue, so that's going to be like 120 degrees. For blue, it's about 240 degrees. For yellow, it's like 60 degrees, and then like magenta is going to be 300 degrees. And then you could also play around with brightness or saturation to get the right color tone that you're looking for. So the reason why it's better to use HSB for computational color is because we're dealing with degrees when it comes to the color wheel itself. So we could stay within like an area of like just shades of red or shades of green much easier that way by playing around with the degrees rather than just messing around with RGB, red, green, and blue. It's just harder to figure out different shades of red by mixing those three colors together. So it's much easier to deal with the hue wheel for hue, saturation, brightness when it comes to that. There are a number of different ways to create color schemes. The ones we will be talking about today have all been proven to work well and are pleasing to the eye. The first and simplest possible way to generate a color scheme is to pick a specific hue and choose colors that are evenly distributed on the brightness scale. You may also take this a step further and modify the saturation. This is called monochromatic. So basically dealing with one color and then just playing around with the brightness or the saturation to create that color scheme. So here's an example of a monochromatic color scheme being used for a Dutch airline company. So you have, I believe, two different colors here. So there's a dark blue and then a lighter blue. So that's pretty much it. And it stays within a very basic color scheme using just one color, but changing the saturation or the brightness to get a variation on that color. An analogous color scheme is a group of colors that are located in a close proximity to one another on the color wheel. Traditionally, these are colors that are about 30 degrees away from each other, but you can play around with that value to get different outputs. One of the reasons why the analogous color scheme is so pleasing to the eye is because it is often found in nature. So when the leaves change colors in the fall, that's an analogous color scheme. Here's an example of analogous colors being used for Wolfgang Weingart's book about typography. So it's staying within the same range on the color wheel by giving us a like orange hue and then like a yellowish hue as well. and those are within the same 15 to 30 degrees on the color wheel. A complementary color is a color that exists on the opposite side of the color wheel. So if we wanted to choose a blue, and the complement would be yellow. If we wanted to start with green, then the complement would be this magenta. If we wanted to start with red, then the complement would be this cyan. Complementary colors were used a lot in the 60s for the psychedelic band posters, and makes the posters feel like they're pulsing or really pops off the page. Today, a number of logos use complementary colors to add a highlight to their brand, to make it pop or add some depth to it. Triadic color schemes form a triangle on the color wheel and are normally about 120 degrees away from each other, creating an equilateral triangle. A quadratic color scheme is a set of 4 colors chosen by placing a square on the color wheel and selecting the colors that fall on the corners. It's essentially a double complementary color scheme. You can also play with rectangular shapes to add more variety and depth. And last but certainly not least, we have to think about grayscale and the contrast from light to dark. Computationally, one might think that you could make a linear range made up of equal steps, but visually, these steps appear to be sharper in contrast at the beginning and significantly less so after about 60%. Now, if we modify the steps to be more visually accurate, it looks a lot better. So when I talk about color, I always like to play this clip from Matrix. Hopefully Warner Brothers doesn't sue me. But this, let me play it real quick. And this kind of is a really good example of how you can use color to add some pop to your designs.
The Matrix is a system, Neo. That system is our enemy. But when you're inside, you look around, what do you see? Businessmen, teachers, lawyers, carpenters, the very minds of the people we are trying to save. But until we do, these people are still a part of that system, and that makes them our enemy. You have to understand, most of these people are not ready to be unplugged. And many of them are so inert, so hopelessly dependent on the system, that they will fight to protect it. Were you listening to me, Neo? Or were you looking at the woman in the red dress? I was... Look again.
So, they used color really well in this scene because it's a sea of gray, a sea of just black, white, and gray suits and dresses. And then all of a sudden a woman in red that is obviously contrasting from all those gray suits pops out. So everyone is looking at the woman in red because of the color. So another thing that you have to think about when you're playing around with color is that different colors also have different meanings and produce different moods. Black is sophisticated, gray is more stability, purple is luxury, yellow is joy, white is goodness, pink is romance, red is danger, blue is calmness, and green represents life, among other things. But considering there are a number of different cultures out there, colors can represent different things for different people. Here's a beautiful visualization that really breaks that down. So it's a little hard to see, so I pulled out 2 different categories to focus on. So here is what they displayed for colors being represented for death and love, but those colors change depending on where you live and who you are and what culture you're a part of. So some of my students in the past have told me that this is wrong or outdated, so by all means, if you disagree with this, then that's fine. But based off of that visualization, so Western and America, they use black for death and red for love. Japanese is black for death and red for love. Hindu is white for death and green for love. Native American is black for death and yellow for love. And it goes on and on and on. So this is just another example when it comes to designing or building anything that is supposed to be visually interesting or visually seen by a large audience. You really have to know who the audience is and understand the demographic that you're designing for. So if you're designing something that is meant to be displayed in America, then you have to know what colors to use and what iconography and different things to use for that specific demographic, versus if you're designing something for someone in India, for instance. Obviously, because we are becoming a much more globalized community, this is probably going to change very quickly over the next couple of years. But it's still something that you need to know and understand who your audience is. If you are interested in learning more about color and color theory, I highly suggest these two books. So The Elements of Color by Eaton and Joseph Albert's Interaction of Color are both amazing books. Some of these books can be hard to find. Eaton's book especially is hard to find. But if you find it, definitely pick it up. There is also a version of the Interaction of Color that was created for the iPad that is actually extremely interactive. So you could play around with different color swatches and click and drag them onto different color backgrounds to see how those colors interact with each other. So it's a really great app that I think it costs like $5 or $10, but I completely think it's worth the money. There's also a pretty amazing game by Method that helps you better understand hue, saturation, and a number of different color schemes. The URL is color.method.ac. I'll add a link to it in the description on YouTube as well as on the class website. So it's a fun little game that allows you to test your color strengths and abilities. So make sure you check that out. So when it comes to color, these are the functions that we're going to focus on when it comes to playing around with color in P5. So the first thing we're going to talk about is color mode. So we are going to mainly be using HSB, which is hue, saturation, brightness, when we play around with computational color, just because it's a lot easier to figure out what color and color range we want to be playing with. By default, RGB is red, green, and blue is going to be the color mode for P5. But using the color mode function, we can change that and override RGB to be HSB. Also in the color mode function, we can change the mapping values. So again, by default, the value is going to be between 0 and 255, just based off of the bits and bytes that we have to work with. But we can change that to be between 0 and 100, or 0 and 360, or 0 and whatever. So if we have one value after the color mode that we're using, then it's going to apply to everything. So it's going to apply a range between 0 and 100 to hue, saturation, and brightness. But if we wanted to, we could apply different ranges to those three values. So it would make a lot more sense for hue to be a range between 0 and 360 because it's a full circle that we're working with. For saturation and brightness, it's more of a percentage, so it makes more sense to go from 0 to 100 and the range in between. Color schemes. So we're going to talk about how we can create these different color schemes that we've talked about earlier in this video using P5 as the tool to generate them. So we're going to learn how to do monochromatic color schemes, analogous color schemes, complementary, triadic, and then we'll talk about quadratic too. So there is a little bit of an issue if you have a hue value that goes above 360 degrees, then it's going to just get stuck at the red value. So to fix that, we are going to be talking about using modulo or modulus operator, which is represented by the percent sign. So basically what that means is that if you divide a number into another number, it's going to give you the remainder after you divide it in whole. So for instance, if we have 460 as a value and we divide and we do modulo 360, then it's going to 360 goes into 460 once and has a remainder of 100. Again, we'll talk about that in more detail in a little bit. So when it comes to opacity, we can play around with that value, that range for opacity as well in color mode. So we have hue, saturation, brightness, and then the last value is going to be the opacity or alpha channel. We're going to talk about using the fill function to pass colors as well as opacity. So fill allows for, in this case, if we're doing HSB, allows for hue, saturation, brightness, and then the fourth value is going to be the alpha channel for opacity. Then there's also a color variable. So if you wanted to create a variable and assign it a color, you can use this color function for creating a variable. And then lastly, we're going to talk about how we can export our designs as images or as SVG graphics, scalable vector graphics from P5. So the first thing I want to talk about is the color modes. So again, by default, RGB is going to be the color mode when you're using P5 out of the gate. And the range is going to be between 0 and 255. Now you could override both of these by changing the color mode to something else. In this case, we could change it to HSB, which stands for hue, saturation, and brightness. And we could override those defaults from being 0 to 255 to be 0 to 360 or 0 to 100, depending on what we're doing. So let's go ahead and make a sketch and play around with color. We're going to play around with these three rectangles and apply a different fill color to each one to make our own color scheme. So let's go ahead and go to the P5JS web editor and create a new sketch. Let's go ahead and create a new sketch. So we don't need the draw function because we are not going to be using it for a couple weeks. And let's change the size of the canvas to be 600 by 400. Let's give it a background color of white. And let's also add a color mode. So by default, it's going to be RGB, but let's play around with RGB first. And we don't necessarily need to define RGB since that's the default, but I'm also going to play around with the mapping values for the minimum and maximum values for those colors. So again, by default, it's going to be 0 to 255. So let's start with that. So this is going to be the default. So it doesn't really matter if this is here or not. This is just what it is. So if I run that, it's hard to see, but we have a canvas here with a white background. So let's just add a no stroke and a rect mode. Set that to center. So the first thing I want to do is create a variable for our rectangle at the top. So var rect size, set that equal to 130. Then we're going to use that variable to draw our rectangles on the stage. Let's draw a rectangle, and let's draw it right in the center. So we can use the width variable, width divided by 2, and then a height variable, height divided by 2, to place it where in the center of the canvas. And then let's just add the rect size for both the width and height. Let's just give this a color as well. I'm just going to make it black for now. We could change that in a second. So we have a rectangle that's in the center and that's black. So I'm going to duplicate this. So if you select it, do Command C, Command V, and I'm going to make 3 of them. So right now they're in the same location and the same size, so we have to offset 2 of them so they're on either side of the center one. So the first one, let's do an offset of minus rect size for the X location. And the third one, let's do plus rect size for the right position. So now we have 3 rectangles. It's kind of hard to see because there's no division. They're right next to each other, but there are 3 rectangles right next to each other. So let's just make them red, green, and blue. So let's do red, green, and blue. Okay, and play. Awesome. So we have a red rectangle, a green rectangle, and a blue rectangle. So this is all using RGB values. So let's play around with HSB now and see what happens. So if we change the color mode to be HSB instead of RGB, then it's going to change from red, green, and blue values to hue, saturation, and brightness values. So the best thing to do when it comes to changing to HSB is to also change the mapping for the min and max for hue, saturation, brightness to be, for hue, a range between 0 and 360, which is 360 degrees is a full circle. So that goes fully around the entire color wheel. Saturation and brightness should be set to 100 because those are more percentage based values. So we want like 50% saturation or 75% brightness. So that makes more sense to have that range between 0 and 100. And let's also throw in an alpha channel. That's also going to be percentage. You can make that between 0 and 100 as well. So let's go back to our sketch. So here, let's change this to HSB. Let's change the hue to be 0 to 360, the saturation to be 0 to 100, and the brightness to be 0 to 100. And let's add an alpha channel to be between 0 and 100. All right, so we just changed the color mode. We didn't change any of the fill colors below. So let's just play that and see what it looks like. Okay, so we lost the color. The first rectangle is black. The second rectangle is black. And the third rectangle is completely white. So if we look at this fill now that's not RGB. Let's decipher, let's try and figure out why it's black and white. So 255 for hue is probably going to be like a green value. 0 for saturation, so it's not saturated at all, and 0 for brightness. So instead of being full brightness, you're basically like turning off the light switch, so it's going to be dark. And in this case, it's going to be black. So the next one, we have 0 for hue, which is red. 255 for saturation, which is full saturation basically, but the brightness is again at 0, so it's going to be black again. For the last one, we have 0, 0, 255. So again, 0 for the hue is going to be red. 0 for the saturation, there's going to be no saturation. And brightness is above 100, so it's going to be fully bright. So there's no saturation, but it's fully bright, which means it's going to be white. So if we wanted to recreate what we did before by doing red, green, and blue, then we have to do this as hue, saturation, brightness. So the first one, let's do red. So red always starts at 0 on the color wheel, 0 degrees. And then let's just do full 100 for saturation. So full saturation, full brightness, 100. Okay, so we have red. Green, I think, is around 120. And let's do full saturation at 100 and full brightness at 100. Oops. Green, okay. And then I think blue is like around 240. Let's do full saturation and full brightness. Great. So we have our red, green, and blue, but instead of creating it with RGB, we're creating it with HSB. So let's play around with code and color schemes. So the first and most basic color scheme that we can create is a monochromatic color scheme. So again, we're going to stick with HSB for all of our color schemes, just because it's a lot easier to play around with when it comes to creating computational color schemes. So basically, the first thing we want to do is pick a hue. So that could be any color. It could be red, green, blue, magenta, yellow, whatever. And then to make a range of colors to work with, we're going to change the saturation and brightness, but keep the hue the exact same. So let's go ahead and play around with that in our sketch. Okay, so for monochromatic colors, the hue is all the same. So the first thing we want to do is pick a hue value for all of these. So I don't know, let's pick a random number. Let's do 230. 230 for all of them. I think that's going to be in the blue range. Okay, so they all are the same color, all have the same hue, saturation, and brightness. So now we can play around with the saturation and brightness to get a variation on that hue. So maybe instead of 100 for the saturation for the second one, let's do 50. And maybe instead of 100 for the brightness for the third one, let's do 25. Cool. So we have a monochromatic color scheme. All of the colors have the same hue. And the only thing that we're modifying and adjusting is playing around with the saturation value and the brightness value. Cool. So that's monochromatic color schemes. So if we wanted to, we can then go in and change the original color. Actually, it's probably a good idea. Let's create a variable. Let's create a var orig color and give that a value of, let's do 100. So now if we change 230 to orig color for all of them, orig color, then hit play, then it changes the value for the hue to be 100. Now it's green. So let's say we want it to be red, then we just change that 100 to 0. And now it's a red monochromatic color scheme. If we want it to be blue again, we could say, like, let's do 300. I guess that's more magenta. But now you're just changing one value and it's changing everything below it as well. Okay, so let's go on to the next color scheme. So the analogous color scheme basically just stays within the same range on the color wheel for the hue, and it's usually equidistant from each other. Let's say these are 30 degrees away from each other. That's an analogous color scheme. You can play around with that range value. It doesn't have to be 30, it could be 15, it could be 10, it could be whatever you want, as long as it's consistent throughout the same area of the color wheel. So to do that, we're just going to add a color range value in and then add that to each one of these original color values. So let's also check that out in P5. So feel free to save this before you make any edits and then create a copy of it if you want to keep the monochromatic color scheme separate from everything else that we are doing. So I'm going to create a variable for color range. Set that to 30. So for this, all we need to do is add that color range to the second one and then add color range times 2 to the third one. Let's keep the saturation and brightness the same. So let's make everything 100 for saturation and brightness. And now let's see what we get. Okay, so we have 300, 330, and 360. So this is an analogous color scheme. So if we change the original color to be range from like 100, let's try that. And we get a range of greens. We can also change the color range value. So if we want to make it a little larger, we could do that too, or smaller. We could do that as well. Let's go back to 30. All right, so if we do something like, let's make this original color 330, like that, then we are going from 330 to 360 to 390, and 390 is above 360. So this is causing a problem. So any value that's above 360 is just going to be red. So what we want to do is when we get above 360, we want to start back at 0 again and make this 30. So to do that, we have to use a little fix called a modulo or modulus operator. So let's talk a little bit about that first before we move on to using it. The modulo or modulus operator basically is giving you the remainder after you've divided a number into another number. So for instance, if we have a value of 460 and we do modulo 360, 360 goes into 460 once completely, and then the remainder is going to be equal to 100. So that's what we get after we divide 360 into 460. The remainder is 100. So that basically allows us to automatically go back to 0 every time we go above 360 degrees. So let's try and add that to our code. To fix this from both being red and stalling at 360 color value, we could wrap these in parentheses and do modulo, which is the %, 360. Same thing with the other one, wrap it in parentheses and do modulo 360. So now when I run this, it should go back to 30. Great. So now this, instead of being 390, it's going back to 30, starting back at 0 at 360 and going back to 30. So that's a really great fix to use for any computational color system that you're putting together. Now, rather than me trying to explain this in more detail, I am going to recommend you guys look at this video that is a guest video by Golan Levin on the coding train, where he's talking about what the modulo or modulus operator is and how it works, specifically when it comes to P5. So I'll add a link to this YouTube video in the description on the YouTube video for this lecture, as well as on the class website for you to check out if you still are confused by this. So the next color scheme we're going to talk about is complementary colors. So a complementary color is starting with one color on the color wheel, one hue value on the color wheel, and finding its complement 180 degrees to the other side. So the complement of blue is going to be yellow, the complement of red is going to be cyan, the complement of green is going to be magenta. So let's go ahead and do that in our code. So because we only really need to be working with two colors here, I'm going to comment out the last rectangle. So we just have two rectangles. So to comment out something, which basically means that it's going to be ignored when you run the code, it's just // and that line or multiple lines is going to be just ignored. So now when I run this code, the code is there, but it's basically like hiding it. So it's not going to be visible when you run the code. Okay, so when it comes to complementary colors, again, it's just finding a hue, finding an original color, and then finding its complement 180 degrees to the other side. So all we have to do now, it's all set up for complementary colors as well. We have to change the color range to be 180 degrees. So when we run this, we have a magenta and then this like greenish color. Then we could change this to be, let's do red and cyan. So basically we are getting an original color and then going 180 degrees around to the other side of the color wheel and finding its complement. So anytime you change this to another value, it's going to automatically update and find its complementary color. So let's go ahead and play around with triadic color schemes too. So again, a triadic color scheme is basically just drawing a triangle on top of the color wheel and finding where the corners of that triangle land to create this color scheme. Essentially, we are just going to go from the original color 120 degrees to the next one, and then another 120 degrees to the next. So let's try that as well. So for this example, we do need 3 rectangles, so I'm going to uncomment the last rectangle by deleting those /. So for the color range, we are going to be changing this 120 degrees from the original, and then another 120 degrees from that secondary color. So it's going to be 100, 220, and then 340. So that's the triadic color scheme. Then if we change the original color, let's try 200. That's going to update the triangle location on the color wheel. So one thing that you could play around with is having the original color be a random value. So for that to work, you have to put all of this inside of setup, because random is a function of P5, and if it's not in setup or draw, then it's not going to know that it exists. So we're going to talk about random functions in, I think, a week or two, but I'll just show you an example here. So if we do random value for the original color between 0 and 360, it's going to find a completely random color in that range as a starting point. So it's going to be a completely random color scheme based off of the triadic color scheme. If we wanted to stay within a range, let's say we just wanted it to be within the reds, we could say like go between, find me a value between 20 and 80. So the original color should be like a red or orange color. Red, orange, yellow. And then the other colors are going to be based off of that original color. So again, we'll talk about random values and the random function in a couple weeks, but I just wanted to show you that you can create like interesting computational and random color schemes by playing around with a random range on load, basically. So the last color scheme is Quadratic, and that is basically just drawing a rectangle on top of the color wheel and finding where those corners lie and using those as your color scheme. So this is basically just a double complementary color scheme. And I don't think we need to do this one. I think you have a pretty good understanding of how to make these. So let's just move on from color schemes to alpha channels. So we talked about fill and using HSB, but we didn't really talk about the alpha channel yet. So with fill, you can pass in a value for, in this case, hue, saturation, and brightness. So hue, saturation, brightness, and then if you pass in a fourth value, it's going to be the opacity or alpha channel. So for this example, we're going to create a new sketch and draw a bunch of overlapping ellipses and play around with the opacity to see what colors we make when we overlap different colors and have a transparent shape. So let's go back to the P5 editor, and I'm going to create a new document. Feel free to save yours so you have access to it again. I'm just going to create a new document and not save. In this document, let's just delete our draw as well. And let's also change the canvas size to 600 by 400. I'm going to give it a background color of 255 for white, no stroke, and color mode is going to be HSB, 360 for the hue, 100 for the saturation, 100 for the brightness, and 100 for the alpha channel. So also I forgot to mention that if you are using color before changing the color mode, then this is actually going to be using RGB, red, green, and blue. Then anything after this color mode here is going to be HSB or hue, saturation, brightness. So you can mix different color modes if you wanted to. I don't know if that's a great idea, but you can definitely do it. Okay, so let's create a variable at the top for our circle diameter. Var d equal circle d equals 250, and our variable for our opacity equals, let's do 50%. Now let's create our ellipses, overlapping ellipses. Let's do the first one at the center, so width divided by 2, height divided by 2, and circle d and circle D. Let's give it a fill. Let's just do black again for now. Okay, looks good. Then I'm going to do the same thing I did with the rectangles. I'm going to copy Command C and paste. Okay, and then we also have to offset. Let's do minus circle D divided by 2 for the one on the left, and plus circle D divided by 2 for the one on the right. All right, so we have overlapping ellipses, but they're all black. So let's change the colors. Let's do red, green, blue. And 240, 100, 100. So these have no alpha channel yet. So there's no opacity, so you can't see through them. But if we added the opacity variable after brightness, then it should be 50% opacity for all of them. And obviously you don't have to use that variable, so if you wanted one to be like 75%, you can just change that to a number. So this one, 75% opacity, this is 50, and this is 50. So it's interesting, you could see like the different colors that are getting created by a green and a blue overlapping at 50%. So you could play around with the alpha channel and opacity and transparency with your objects as well. So when it comes to variables, we've mainly been using variables to represent like a number, but you can use a variable to represent a color. So if you create a variable name, it could be color name, it could be whatever you want to call it. and then set that equal to the color function, and then pass in the color values. That color name variable is always going to represent those color values. So if you want to use that color multiple times throughout your code, then that's the best way to do it. So that's pretty much it when it comes to color. So the next thing I want to talk about is exporting. So the easiest thing to do is to export an image from P5 because that comes standard with P5. So the first thing you want to do is create a variable name for your canvas. So you can call that, again, whatever you want. We're just going to use C as the example. And then you just have to use the save canvas function at the end of your code. Pass in the canvas name, canvas variable name, the file name that you want to save it as, and then the extension, so the type of file you want to save it as. So I believe the only two options are JPEG and PNG when it comes to exporting images from P5. So that's what you would put in for the extension. So let's go ahead and export our opacity example real quick. So at the top, I'm going to create a variable var c equals create canvas. And then at the bottom, after all my code, so you have to have all the code run first and then you export the image. So we're going to do save canvas. And first thing is the canvas, which is C, var C. Then the name, let's do opacity. And then the extension, let's do PNG. Okay, so now when you play this, you should get something that pops up like this to save the file. Or I think if you're using Safari, sometimes it automatically just downloads to your downloads folder. You might also have to give the browser access to download. So that's also a possibility. If it's not working, then it's probably something to do with the browser not having access to download images. So if we hit save to the desktop, then let's go and check it out. So it's on my other monitor, but here it is. So this is a PNG image that we exported from our P5 sketch. Pretty cool. So if you wanted to export something other than an image, there is another library we could use to export vector files. So this library is on GitHub, and it's called the P5 SVG library. Basically, you just need to go to this link. I'll provide that link for you in the description on YouTube as well as on the class website. And then we just need to say create canvas, give the dimensions, then define it as SVG, and then hit save. But before we do that, we also have to add this file to our HTML file. So let's go ahead and go to this link and copy all that code and put it into our own sketch. So let's paste that and go to that GitHub account. And then I usually just like clicking on raw. And then you could do Command A to select all, and then we can copy it. And then go back to the P5 editor, your sketch that you've been working on. And then we can open up our root directory, click on this down arrow, and we can say create file. And let's call this P5 svg.js. And then in this file, we just paste all that code and save it. And then go over to our HTML file, and we have to link that code, that JavaScript file, to our HTML document. So if we go script source equals, and the name of the file is p5svg.js, and then close that script. And then let's go back to our sketch.js. And we don't really need this variable anymore, so I'm going to delete that. And we're not going to use this save canvas, so let's just comment that out for now. But we do need to add another value to our create canvas function called SVG. And then at the end of our code, we just want to use the save function. So these are referencing the P5 SVG library that we just installed and linked to our HTML document. So if we didn't go through that process, then this wouldn't work. This function wouldn't exist. So let's try and run that sketch and see how it goes. Cool. So we could change the title if we wanted to here, saving as an SVG file, and let's just save it to the desktop. Let's go opacity again, .svg. So let's try and open that as well. Cool, so there's the SVG, and just to prove that it is a vector file, let's open it up in Illustrator. All right, that looks good, and let's try and click on some of these elements. Cool, so we have a vector file that we can manipulate further if we wanted to and play around with. So this just shows that you can use P5 as another tool in collaboration with some of the tools that you're already used to. So you could design something like a pattern or something in P5, export it as a vector file, and then open it in Illustrator and do some more modifications to it. The SVG library also allows you to import SVG files to P5. So if you want to design something more complicated in Illustrator and then save it as a SVG file, you can bring it into P5 and do some manipulations with it. So for this week's project, I want you to take the posters that you designed for last week's homework and play around with different color schemes for them. So I would suggest looking at doing different color schemes like Monochromatic, Analogous, Complementary, and coming up with an actual color scheme rather than random colors. So that's basically all I have for today. Check out the homework assignment on the class website. And again, if you have any questions, please let me know on Slack or on email. I'm always happy to help. Thanks.